Thank you very much for inviting me to give this talk. I do hope it won't be a disaster. What I want to do is talk about some work that I've been doing on disasters. This is joint work with Elizabeth Frankenberger. We co-direct this project, and this is truly team science, and the work I'm going to talk about today involves all the collaborators that you can see on this list. So instead of talking about disasters in general, I talk about a disaster that I know something about, and that would be the 2004 Indian Ocean tsunami. This was a very large scale, unanticipated negative shock. Why do I want to talk about it? I think it's important for us to understand the impacts of these kinds of shocks on lives and livelihoods. And while there are unique features to the 2004 tsunami, it's not a unique event. The tsunami impacts on the environment, both the natural environment and the built environment, parallel the effects of several of the disasters related to climate change, especially hurricanes, flooding, and seawater inundation. And we know that those disasters are increasing both in frequency and severity. What I'm going to do today is try and give a little bit of value added to you by describing some impacts on population health, cognitive performance, and some economic choices, drawing on this broader research program that we've embarked on. So the 2004 Indian Ocean tsunami, it was a disaster. It was devastating. This is some of the debris from a couple of years post-tsunami. At 8 o'clock in the morning on Sunday, 26th December, there was a 9.3 Richter scale earthquake off the coast of Sumatra. It shifted the North Pole by several centimeters. At the time, it was the largest earthquake ever recorded, and it spawned a tsunami that was felt across the entire Indian Ocean. The tsunami, the earthquake, was just off the coast of Sumatra, which is the northernmost island of Indonesia. The tsunami was felt right through to these brown areas over on East Africa. The epicenter was about 150 kilometers off the coast of Aceh. The tsunami surge was about 800 kilometers an hour. And so it was only within about 20 minutes that after the earthquake, the tsunami hit the coastline. This is an area that was not thought to be prone to tsunamis. The last tsunami that had been experienced on mainland Sumatra was 600 years ago, based on archaeological evidence. And in addition, it was thought that the Pacific was not going to ever spawn a tsunami. So therefore, the Pacific had no early warning mechanisms, any early warning buoys that would tell people about, would inform people about a coming tsunami. This was large and unanticipated shock. Some people who are living on this coastline along the west coast of Sumatra experienced wave heights up to 15 meters. The mud reached up to about 6 kilometers inland in the worst areas, and the coastline was permanently shifted by up to 1.5 kilometers. It caused about 170,000 deaths. That's about 5% of the population of Aceh. 700,000 people were displaced, and there was about $4.5 billion worth of damage. Some guess there, obviously. It damaged the built infrastructure dramatically, natural infrastructure dramatically, and also reduced access to food, water, and markets. Some communities were completely devastated. At the worst of communities, there would have been something like 60 to 70% of the population was perished in the tsunami. The tsunami was followed by a massive influx of aid and assistance. About 7.2 billion was directed to recovery in Aceh and North Sumatra. Initially, for the first couple of years, that was directed at providing emergency food and temporary housing in camps. And then later, there were investments in infrastructure to rebuild the communities. Here you can see how bad the tsunami was. This is villages not from our study, from Kuala Kala and Aceh. On the left-hand side, this is satellite imagery, 3 days before the tsunami, and the right-hand side is imagery 3 days after the tsunami. You can see that the built environment was completely just wiped away. The aquaculture was wiped away, and the agriculture up in the top plain up there, the coastal plain up there, was also just wiped away. But there was also growth. 5 years later, you can see that although the coastline has shifted and the aquaculture never came back, the village has been rebuilt, albeit in a different place, and the roads are in different places. And that's what you should be thinking about as this disaster, a complete disaster that turned productive assets into brown earth, and then some rebuilding post-disaster. This was called Build Back Better, and it's one of the largest reconstruction efforts in developing country. So let me talk about data, or the data that we're going to talk about today. So we call our study the study of the tsunami aftermath and recovery, STAR. And SUSANAS, as many of you already know, Statistics Indonesia interviews households as part of SUSANAS in nationally representative socioeconomic surveys in February of March 2004, which was 9 to 10 months before the tsunami. SUSANAS interviewed about 30,000 respondents along the coast of Aceh, North Sumatra. The this SUSANAS designed to be representative at the population level for the Kabupaten, which would be like a county in this country, and includes both areas that were more and less affected by the tsunami. So what we did, we used that as a baseline for tsunami, baseline for STAR, and we, in collaboration with Statistics Indonesia, went to try to resurvey the people who had been interviewed in the 2004 SUSANAS. And our goal was to interview all baseline respondents. So we had the baseline, and then starting 2005, and then carrying through to about 2006, we did our first year follow-up. It was hard. It was hard because we didn't even know which areas had been damaged because no one had been able to map this. The satellite imagery I showed you a moment ago was actually only produced about 3 or 4 years after tsunami. And so our goal was to first determine survival status of all the respondents. And for people who we could find family members, that would be something we could get pretty good information on. But for people who had the whole household had moved away, or all had perished, that would be much more difficult. And so we tried to get at least three pieces of information to determine survival status. And then we tried to interview all the people who were survivors, i.e. people who we had not determined had died. And in the hardest hit areas, the majority of people moved away, half of them to camps and half of them to private homes. That would mean that if we had only gone and interviewed people who were still around, we'd had a very selective sample. So it was tough. But nonetheless, we did actually interview 91% of the baseline survivors, or people we thought had not died. And that was our baseline attempt, our first follow-up. We then did 4 more annual follow-ups. And in every wave, we tried to find the respondents who we thought had survived or had not died. And of course, we didn't want to just go for the people we already found. We want to try and find everyone else. And so we would not have a cumulative attrition. That seems to us to be a very important principle. And in fact, by the end of the 5th follow-up, we had interviewed 98% of the baseline survivors at least once. Not every time, obviously. We didn't in the first follow-up, but at least once. We then did a 10-year follow-up. We did a follow-up at the 13 years, which was a subsample where we did an extended assessment of biomarkers and cognition, and I'll draw on that data now. And then we've just finished up a 15-year follow-up because of delays because of COVID. And in that, just to give you a sense of how we're doing on attrition, we've interviewed 93% of the survivors at the year 15 follow-up. Of course, we've discovered some people who we thought had died actually had not died, and they've been brought in as being survivors. And then some people who we thought were survivors, we found actually had died. And so, but that's trivial. It's, something like 50 people total out of our 30,000. All right. So here is the study areas. These dots are our enumeration areas. We have 420 enumeration areas in these coastal Kabupaten in Aceh and North Sumatra. And red designates, these are the areas that were heavily damaged by the tsunami, which is based on the satellite imagery, inspection of the satellite imagery that I showed you before and after the tsunami. And the blue areas were areas that had no direct damage. It's kind of hard to see anything because the dots are all on top of each other. So let me blow that up on the right-hand side, and you can see I've got 3 designations, but essentially the black are the heavily damaged areas, and the gray and white are the white are not damaged and gray are in between. You can see here that the places that were damaged were very, very close to, that were heavily damaged, were very close to those that were not. And this is because damage is a function of the topography of both the land and the seafloor, which would determine the wave height and wave direction. And the way to think about this is if there was a promontory or some elevation between 2 areas, one area could be very badly damaged and the other area could be largely protected. And so that's a sense in which We think of the tsunami as being the damage that you were exposed to in the tsunami as being not really under your control ex ante. So we'll use as one of our exposure measures the extent of damage in the community that you were living in at the time of the tsunami based on our pre-tsunami baseline. So clearly where the tsunami hits not under your control. In addition, the tsunami, as I said, was completely unanticipated, and there were no anticipatory behaviors. People were not trying to run to the hills, which is the right thing to do when the water is starting to recede because the tsunami is coming. In fact, people went down to the beach to go and collect the fish, which is one reason why mortality was so high. In addition, in the baseline, there was a question about what is the probability you're going to have an earthquake or a tsunami, and that was about 2%, 2.5% for the in overall. And there's no difference between the areas that were heavily damaged and not heavily damaged. So there's nothing that people were expecting these things to happen. But nonetheless, were the people in these communities that were effective, can they be treated as being random? And so a conditional being in a I'm going to use not the Kabupaten, but a Kecamatan, which is a sub-district below the Kabupaten, and think of it as a bit like a zip code. Because I don't want to compare, for example, people who are living in Banda Aceh with people living in rural parts of, say, Nias, one of the islands of Sumatra, as that's not going to be a fair comparison. So we'll compare, when we do our comparisons, we'll compare within Kecamatan and then just make control also for being coastal, because if you're away from the coast, you won't really likely be exposed. And with that, I can show you, here's some characteristics of people, differences in characteristics between people who were in the heavily damaged areas relative to those who were not directly damaged or not heavily damaged. And you can see that there's just no differences. Here are the mean gaps and standard errors for those gaps, and they're all not close to being statistically significant. And overall, the joint test for these ones, and I can show you a whole lot more, but that's not what you're going to want in a 45-minute presentation. Joint test is they're not statistically significant. So we draw the conclusion that these sorts of comparisons between the heavily damaged and not heavily damaged can plausibly given a causal interpretation. And obviously, we need to establish that for each of our studies. But we've done that in things I'm going to talk about. And I'm just going to say, leave that as an assertion for now, and we will show you some results. So let's start with tsunami mortality. At the time of the tsunami, here is mortality in the areas where there was no direct damage for males and females. And those would be for the whole of 2005, because otherwise there was very few people who died in the 3 or 4 days after the tsunami. Those numbers there replicate the sorts of numbers you'd get from life tables. This is the death in the heavily damaged areas, just staggering. About a third of the population was killed. You can see that for females, it's not much related to age, but for males, it really is. There's an advantage if you were a prime age male, and that's a reflection of two things: strength and the ability to swim. Women don't learn to swim in Aceh, and so that drives the vast majority of that gap. Let me move to post-tsunami health and cognition with that as your background and context. And I'm going to start with an obvious endpoint, post-tsunami mortality. How did the people, what was survival like after the tsunami? Well, there's two competing characteristics, features here, forces. The first is the people who were exposed to the tsunami might have been scarred and therefore more likely to die. But there's also those who were survived the tsunami were the healthier, and so therefore there would be selective mortality on health, and so the healthiest would have survived, and so therefore the people who were exposed would be more likely to actually live during the post-tsunami period. And I'm going to look at the 15 years post-tsunami, and instead of just doing heavy damage, not heavy damage, I want to get a sort of dose-response type effect to show you what's going on. And I'm going to use, instead of just heavy damage versus not heavy damage, the percent of the population that died in the community of residents at the time of tsunami, and that, and then I'm going to compare mortality rates for people who are aged 35 or older at the time of the tsunami. Here's the picture, and you can see that this is the percent dead on the y-axis, the percent who died in the community on the x-axis. So the 0% is all the not damaged areas. on percent who died. And so that estimate is very, very tight. And then you can see there's a little blip up, but then there's a downward sloping curve. And as I said, that's got to be attributable to selective survival of the people who made it through the tsunami. When we do, that was just raw numbers. When we do regression analyses and we adjust for Kachamatan, split them up by age, you see that actually this selective survival piece is really driven by older people, both males and females, and there's a significant, so you're significantly more likely to survive 15 years if you had a worse exposure to the tsunami, as indicated by the percent dead. I want to turn next to talk a little bit about psychosocial health and the effects of the tsunami. Your clock's wrong. Oh, that's better. I had a little cortisol shock. So I'm going to look at post-traumatic. I'm just suffering some post-traumatic stress from that. Post-traumatic stress symptoms. At each follow-up in STAR, we asked about 7 post-traumatic stress symptoms related to hyperarousal, avoidance behavior, event re-experience, designed to be specific to the tsunami. And we asked about the presence and severity of each of these and score them so that there would be a score of 0 to 21, and we're going to call that post-traumatic stress reactivity. This looks a lot like post-traumatic stress diagnoses, but we're not doing any diagnoses here, and so we call it reactivity. At the first post-tsunami follow-up, we also asked about your worst experiences, and so we can get something about how it was immediately after the tsunami. And then we repeated that same follow-up, and the correlation is very high. So we think people are able to recall this pretty well, which is consistent with what you would see in the literature about recall bias. If something's really, really salient, you typically recall them very well. So here is the level of PTSR on the y-axis, and here's some tsunami on the x-axis. And you can see that levels are elevated for those who are in the heavy damage areas, but even in the no direct damage areas, people are presenting with very high levels of PTSR. A year later, they've gone down a lot, and 2 years later, they've gone down even more. And by 5 years later, there's still an elevated PTSR, but the gaps between the heavily damaged, not heavily damaged, are very much smaller. They're still significant. There's 95% confidence intervals around there, those circles, but they're not clinically important by any stretch of imagination. And then as we go out further, they really are very, very, very similar. That is to say that the tsunami has left fingerprints on these people's lives, both for the people who have exposed most dramatically and those who aren't. So that I introduced because that's our third measure of exposure, post-traumatic stress reactivity. That has 2 advantages. It's individual specific, as opposed to where you were living at the time of the tsunami. And now when we include in our models, instead of just having Kachamatan fixed effects, we can actually control for how bad was the tsunami for you and how you reacted to that by including community level enumeration area fixed effects. Of course, what we can't do is interpret that as causal, because that may well reflect all sorts of pre-existing differences pre-tsunami. All right, but what I can show you, which is interesting, is that when I showed you the mortality a moment ago, it was comparing people in heavily damaged versus not heavily damaged areas, and we had that there was selective survival of the fittest from the tsunami. But among the people, for the males, who had very high PTSR in the first 2 years post-tsunami, those people who, for the tsunami, took a huge psychological toll, we see actually for them, the mortality is, there's a missing negative sign there, that the people, oh no, this is mortality, excuse me. So this is mortality. Mortality is higher. And so these people who had high PTSR indicating that there is some evidence of scarring for the people who had the worst psychological experience. And so we've got both selective survival overall in the population, and then the people who had a really bad time, we can see some markers of scarring occurring, and that's starting to emerge only now. There was no such patterns 5 years after the tsunami. But let me turn now to getting under the skin. Why do I want to do that? When I showed you these PTSR effects, I could have done something like, well, what was general health status, or other sort of self-reported health status markers? And I would have shown you very similar sort of patterns, that there were gaps in the first couple of years after tsunami, but they very quickly become very muted. And so what we thought we should do is look at biological risks of health problems linked to health outcomes. And we know that stress affects the HPA axis function. We know it affects the immune function. And there is a literature saying that it affects cardiometabolic health. Some of that literature is very clearly causal. Some of that literature is more correlations. We started out, I'm going to show you two markers. We started out with C-reactive protein, which is a marker in the blood, which tells you about inflammation. Elevated CRP has been linked with worse cardiometabolic health, elevated risk of heart disease and strokes, with cancers. And during COVID, elevated inflammation was one of the markers that resulted in people having been put onto ventilators. And so they were measuring inflammation to try to track people's responses. In heart disease, normally you think of BMI, elevated BMI, as being a big predictor of heart disease. Actually, CRP is a better predictor of heart disease than BMI. Even after you condition on BMI, CRP is a significant predictor of heart disease. And so this is thought now to be a pretty good general health measure, and is quite widely used. So we decided to measure CPR and examine the impact of exposure to the broad set of stresses of the tsunami, the experience of seeing the tsunami, the loss of your livelihoods, loss of family members, loss of community, and also the damage to your own well-being. And we'll look at that on the evolution of CRP of adults. And I'm going to show you here, this is conditional on age and gender and education, and then also pre-tsunami kecamatan, fixed effects. So we're comparing people who we think are pretty alike. And we didn't collect, so we do CRP of dried blood spots, which is relatively straightforward technology. We did not collect dried blood spots in our first follow-up of the tsunami. In our first follow-up of the tsunami, all we did was try to find people. And so we were not wandering around with huge amounts of biological marker measurement tools. And so in the second year after the tsunami, we can see that this is all in log terms. So there was a 15% increase in CRP among those who were living in the heavily damaged areas relative to those who were not. And that tends to increase over time for the first 5 years, and then at some point starts declining. So this suggests that there were cumulative effects that actually accumulated and got worse, and then there's some evidence of improvement. Interestingly, what we find is that that pattern is much clearer for women. There's no significant difference between males and females for the first 5 years. Males are slightly lower, but not significantly so. And so one doesn't want to make much of that. But after the first 5 years, females seem to consistently have elevated CRP relative to males. And I told you before that this may be something to do with mortality selection, because we had that mortality selection effect for males. It's not. When we just do this for people who are not even close to getting to mortality selection type analyses, we see these same patterns. It's something about the males having a greater level of robustness in terms of CRP than females, suggesting there's some additional behavioral effects included. So we then decided, okay, so what's driving all of this? We figured, well, that was we started with a very natural endpoint, mortality. We then turned to a more general measure of health that we can't really pin to anything specific, CRP, an inflammation marker. Why don't we try and look at stress hormones, which we know should be directly related to exposure to the horror of the tsunami, broadly defined. And we only did that 13 years post-tsunami in that subsample I told you about. So what do we know about cortisol? We know it's elevated when you've exposed to some kind of mechanism that's going to drive a fight or flight response. It's healthy for this to be the spike. You expect elevated cortisol immediately after the tsunami, but that should be deactivated when the stressor ceases. So we should see spike and then some decline. We only measure the cortisol 13 years later. A healthy response would be there'd be no difference between exposed and non-exposed people. That would be good news for us. However, if in the long term, there's been dysregulation of the HPA axis that drives the cortisol response, then it's possible there would be elevated cortisol among the people who were worst exposed. Although there's also literature that says that repeated consistent cortisol elevation has been linked to reduced cortisol levels, hypercortisolism, which is referred to in the literature as burnout. So people who have really, really bad cortisol, elevated cortisol, elevated stress for an extended period of time, you know, like I'm feeling right now, no, really extended period of time, then we have evidence, and this has been shown, for example, for people in very stressful jobs, like ICU pediatric nurses. They actually show evidence of hypercortisolism, or this burnout, as Bruce McEwen called it. So we figured we're not sure which way this is going to go. We'll measure cortisol levels. That's a little bit difficult. Mostly it's measured in saliva. It's easy to measure in blood and urine. The problem with cortisol is it varies diurnally. So cortisol will peak a little bit after you wake up. You wake up because cortisol's rising. It then declines through the day. And so if you want to measure cortisol levels, you need to measure it multiple times through the day. It's not that it peaks at X minutes after you wake up. It peaks at some point, and it's not clear where it declines. It varies both by day and by individual. So you would want to measure this thing many times during a day, and ideally, you'd want to measure it over multiple days. And while most literature in the past has looked at sort of the area under the curve in this cortisol map, more recently, the sort of state-of-the-art today, best practice, is to look at the gap between the peak and the trough, the diurnal range or dynamic diurnal range. And that really requires a lot of measurement. And that's kind of hard for us to do without, you know, kind of moving in with all of our respondents. So what we did was we measured hair cortisol in the hair. Because, of course, cortisol gets secreted into all the organs, and it gets secreted into hair follicles. And so you can actually measure the amount of cortisol in hair, which is not going to be a measure of cortisol at that moment, obviously. It's a measure, it's an integrated measure. It's cumulative HPA axis activity, and it integrates cortisol levels over time. So what we did was we collected hair from the back of the scalp. You got to go right into the root. You don't want the edges. And we collected about 3 centimeters of hair. And since hair grows about a centimeter per month for most people, that is likely to be about integration over 3 months. And then what we do is adjust for weight and measure cortisol concentration in the hair. So we've got, for that period, which is somewhere around 3 months, what is these people's cortisol level? And what I can show you is that for the people who were living in heavily damaged areas at the time of the tsunami, there's evidence of reduced cortisol among females. And it's significantly reduced. So this is this hypercortisolism, or extended stress, and we don't see that for males. Moreover, not only is that true, but we also see that for the women who presented with elevated PTSR during those 2 years post-tsunami, they also have lower cortisol that is significantly different from others, and that's after controlling for community-level fixed effects. So that suggests that these women, 14 years later, are actually suffering from what I called burnout, which we know has negative consequences for health downstream. And so that seems very troubling, and is one of the reasons why we felt like it was important to not just stop with CRP, as it sort of gives us a greater context for understanding, for interpreting the inflammation results I showed you. Great. I then want to turn to tsunami-related stresses and cognition. So if we know that stress has shown up in biological markers for these people. We also have a literature that says stress is really bad for brain health and therefore potentially for cognition. And so what we figured we should do is look at some cognitive markers and see if we're seeing any differences in cognitive performance between those who are exposed versus those not. Now, we shouldn't expect to see this in things like a Raven's matrix assessment. Those embody all sorts of markers of cognition. And so what we figured we should try to do is be very, very, very focused on specific domains of cognition about which we have a literature. And so this work is in collaboration with neuroscientists. And so let's start with one well-established result. And that is that exposure to stress results in disruption in associative learning. I'll tell you a bit more about that in a second, and hippocampal function. And those effects are known to increase with great exposure. That result is on human populations, which is largely correlations, but also in animal models where there really is causal evidence. And it's the literature is very clear that there's a negative impact of of elevated stress, really bad stress, that on this associative learning capacity, and this persists over the long term. Potentially, associative learning is quite important for lots of our processing. That could affect all cognitive domains. So maybe that would affect Ravens, and so we'll think a bit about that. But after the exposure, it's also the case, the neuroscience literature has established, that there's scope for new skill acquisition. So you have a terrible stressful event, and then there's new skill acquisition. You can offset that, at least in some domains of cognition, because you can grow cognitive capacity and shift the underlying neural structure, and that's based on MRI analyses. And that would be true not just in young kids, but also in adults. And so what we don't know is what would the impacts of this stress be on these other domains of cognition, given it wasn't just that you were exposed to the horror tsunami, but there was all this post-tsunami growth from the Build Back Better. So in the 13-year post-tsunami assessment, where we did these extended biomarkers and cognition, we assessed performance on specific cognitive tasks. We did 6 tasks. I'm going to show you 2, not because I'm selecting, because I don't want to go over time, and I want to have plenty of time for questions. These cognitive tasks have a foundation in neuroscience and linked to specific domains of cognition, and they were developed in collaboration with Margaret Sheridan at UNC. So the first task I'm going to talk about is called declarative memory. It's a measure of associative learning. It's declarative memory is the ability to encode, retain, and retrieve information where you have explicit intent. And the reason we're measuring it is that it indicates your ability to acquire new knowledge and to learn from that experience. And I'll show you the test in a moment. We start here because that's the marker I told you before, for which there's robust evidence that there's a negative and persistent effect of stress on the brain, on this particular domain of neural functioning. So how do we measure it? How is it measured in our study? There's many, many, many measures. This is a very standard measure. Margaret designed them, but they're designed from there's a whole panoply of tools out there. And so we just designed them so that they were they did not require literacy. We could give them to people of all ages, and that they were very, very easy to explain and very, very easy for people to do. And they're just done on laptops. So what you do is you show someone a shape at the top of the screen, and you ask them, what is their pair? Well, the first time you see that, you say, I have no idea. So you make a random guess, and you're going to get it out right 25% of the time. And then you carry on poking away until you get it right. And so then you learn which one is the pair. And we'll do 6 pairs, and then we'll repeat that 3 times. You'll have 4 times altogether. And so the second time, you should have learned something. And then the third time, if you don't, you'll poke around till you get it right. So the second time you'll learn again, oh, the square is actually matched with the blobby thing in the third space there. And then you get that the second time, the third time, and the fourth time. And what we're going to do is, the standard in the literature is to treat, did you learn it, by asking whether you got the right pair on your first guess. So first time, it should be 25%, and it is on average for our people, so that's not a problem. But the second time should be higher, and that would be how much learning there was. And from a hole-in-one, if you like. So I'm going to show you relative to the first presentation, which was a random guess. I'm going to put in respondent fixed effects because it's all going to be differences here. And I'm going to show you what happened among people who were in the sustained, who had sustained heavy damage, who were in the heavy damaged areas. And you can see they did slightly better on the second presentation. They 27.3% got it right, and then better, and then better. So there is learning going on, but the learning is greater among people who were not exposed to the heavily damaged communities. And that difference is actually significant for the first presentation. And whilst it's still negative, it's not significant after that. So this is clear evidence that not only are these people showing elevated biological health risks, but there's also some evidence of this going through to the brain. So let me repeat that third column right here. So it's just the same column. And go to the dose response analysis, which is the fraction who died in the tsunami, because that was a pretty crass measure, heavy damage, not heavy damage. What about if you had a worse exposure? Are you doing worse? And the answer is yes. In fact, quite a lot worse. And so this is also evidence that the stressor has this long-term negative impact on this particular domain of associative learning, on this particular domain of cognition, associative learning. And then when we looked at PTSR, it was just extraordinary. Really, really high levels of impacts or evidence of deficits in this associative learning. And so exposure to stress is clearly related to this deficit in associative learning. All of these models include respondent fixed effects. They're all differenced. And so we would say, given the literature, the way this is designed and the research design, this is pretty likely to be a causal result that the associative learning, long-term impacts on associative learning there's a deficit. And that was sort of, in a way, good news from the research design, because it suggested that what we'd done, we'd measured this thing correctly, it was consistent with the literature, and that that's sort of a pretty good test of the whole approach. Then we turned to markers that would be more related to things we would be familiar with. And I'm going to show you, we've done this with a bunch, and the results for all the others are very like this. But I'm going to show you a marker, a measure of executive function, essentially planning and execution, which is related to problem-solving strategies where you match patterns. So we assessed the task, assesses planning, self-control, and memory. And why did we want to measure it? Well, maybe these people are going to show deficits in executive function as well. But it's also possible there was scope for post-tsunami growth because of the build back better and having to rebuild your life. So we're going to do a standard tool. It's called Stockings of Cambridge, Tower of Hanoi, Tower of London. There's a whole bunch of names for it. The idea is there's 3 balls of different sizes, and you have to have the smallest in the bottom, the next smallest in the middle, and the biggest at the top. And your job is to move the balls. You can move them one at a time, and the balls always have to be in a sock. You can't leave them up on the side or anything like that. And then you move them across. And that one's incredibly trivial, and you can all do that in 2 seconds. What we did was we gave them 6 tasks of varying difficulty. And so here's another task, and that one is considerably more complicated. You really have to move balls around quite in a quite non-linear fashion. And the measure we're going to use to see how well these people did was count the number of moves it took for them to complete the task, to get their balls into the right-hand sock. And I'm going to use whether they completed with optimal moves in the optimal number of moves, only because that's a very simple measure. And there were some people who were flipping around with, here, there, here, there, here, there, here, there. So we have some guys who are on to 30 or 40 moves, which, not terribly helpful. So I'm going to use this. Whatever I use, my results are all going to be the same. So let me show you in the heavy damaged areas on the first trial, which was actually that first one I showed you, 94% got it right. And in the heavy damaged areas, but then they got harder and harder. And by the time you got to the 6th one, only about 38% were getting it right. In the not heavy damaged areas, It's not terribly different, but it is different, and it's actually significant. And now it's positive. So on associative learning, the heavily damaged people performed worse. They have a deficit. But on executive functioning, they're actually performing better. Well, maybe that's because they're smarter. And the people in the heavily damaged areas were pre-existing smarter or something like that. So let's do at least a diff and diff and take out pre-existing differences. And you can see that that still is significantly positive. People who are exposed to the tsunami are doing better on this marker of executive function. I'm not going to claim we should all go and be exposed to a tsunami. But when we use the dose response approach to measurement, we see actually not only is it better, but a lot better. And those effects are bigger, as we've seen elsewhere. But among the people who had really big psychological costs, not better. Okay, so what the hell is going on? We have a deficit in associative learning, which we expect based on the literature, because that's known to be impacted by stress over the long term. But we have an advantage in planning and execution, but not if you had elevated PTSR. Well, if you were exposed to the horror of the tsunami, you were also exposed to having to navigate your post-tsunami landscape. A landscape where you lost your livelihoods, you lost family members, you had to rebuild whatever resources you had, whatever business you had, and that landscape was largely new. You would not be drawing on what you had learned before. You'd have to navigate either a new area or a whole lot of reconstruction coming in, and that would demand skill acquisition. And maybe that's more difficult for people who had really elevated levels of PTSR, and they weren't able to actually navigate it as well. So we can investigate that using the longitudinal design of the study. And I'm going to just talk about these very briefly because I want to I want to have plenty of time for questions. So we did ask questions about willingness to take risk. And we asked those in the second and later waves of the of STAR, so the first post-tsunami survey. We set it up as choosing among different hypothetical monthly income streams. This is not, in the economics world, we call these, choosing amongst gambles. We don't use that language since gambling is not something that is approved of in a Muslim population, Muslim context. So we talked about hypothetical monthly streams. One was certain amount of money, and the other was uncertain with a 50-50 probability. And then we changed the amounts involved in the uncertain streams. And to summarize the evidence, what we found was that in the heavily damaged communities, the people chose the riskier option in the first year post-tsunami relative to the others. But after 2 years, there was no difference in willingness to take risk. So what we saw was people had to take risk that they had not necessarily been willing to do in the past. And that was because they needed to pick up either a new opportunity or some kind of business or something. And in fact, we do know about starting US businesses, and we see that those who were in heavily damaged communities of tsunami were more likely to start a new business relative to others. That was usually around about year 3, 4, and 5. There wasn't a ton of new businesses being started, or at least not what they would call a business, immediately after the tsunami. And so this is consistent with navigating this new landscape and with the executive function advantage. And we think it gives us a way to interpret the evidence, broadly speaking. So with that, let me just give you a few what I consider to be takeaways from what I think we've learned from the whole broader research project. First, to me, it's extremely clear that if you want to talk about large-scale disasters, you need to look both at the short-term and long-term. The short-term effects were very different from the long-term. And so knowing what happened immediately is super important, but actually following these people over the long-term seems to me to be really, really first order. It's clearly important that we track evolution of outcomes, and it's absolutely imperative if we're going to ever say anything, not just about resilience, but also about recovery. Some of these people really recovered. I did think about presenting a whole bunch of stuff on consumption, income, and wealth. And that would have been a different talk. So I decided, I thought this would bring more value added, but just to say that what these people had to do, you can see in consumption, income, and wealth, the people exposed to tsunami, they had to do all sorts of things with their consumption because now they had to go and find a house to rent or go to a camp. And you can see that reflected in consumption and also in their sales of all their sales of assets. So I think that for us to understand resilience and recovery, we need to follow people over time. There's enormous heterogeneity in the population, and it's super important, as I just said, to look at a multiple array of dimensions of well-being. I focused on health and cognition because I thought those might be interesting because we don't usually do those in this sort of context. But the consumption, income, and wealth has the same sort of parallel. And without that, I wouldn't be as confident about the interpretation I've given. And then finally, it seems to me absolutely critical. We really spend time trying to measure exposure to the event. I showed you 3 different measures, and they all sort of told you a somewhat different story. I think that's really, really key. And that's it. Thank you all very, very much.